Metrics are red on checkout. Pager is loud. Someone pastes a request ID into Slack and asks for the trace. You open the backend. You search. Empty. Not a partial tree, not a broken parent span, nothing with that ID. A teammate says we sample at 1% in the SDK. We always have. That setting did its job. It also lied about this incident. The slow checkout never won the dice roll, so your vendor never stored the only story that could locate the fault. Head sampling is honest about volume. It is not honest about pain. If your keep rate is 1%, 99% of rare failures are invisible by design. Tonight, we stop pretending that is an incident strategy. We put tail sampling in the collector. Decide after the trace exists. Keep what a war room needs. Drop the boring rest before it burns budget. If you watched OpenTelemetry 101 on this channel, you already know the loop. Metrics detect, traces locate, logs explain when they share context. That loop has a silent precondition. The trace has to exist in storage when you go looking. Sampling sits in front of that precondition. Cut the wrong traces, and locate becomes a shrug in the war room. You are not tuning a pretty flame graph. You are choosing which failures you are allowed to reconstruct at 3 a.m. Cost pressure pushes teams toward aggressive head sampling. Incident pressure pushes the other way. Tail sampling is how you hold both without lying to yourself. Keep the traces that answer pages. Drop the ones that only inflate the bill. Head sampling decides at the start of the trace, usually in the SDK sampler. Parent-based, with a trace ID ratio-based route, is the pattern most services copy from a template. Parent creates a trace ID, flips keep or drop, and children obey the same decision. Probabilistic 1% means 99 of 100 routes never become recorded traces. That is rational when traffic is huge and most calls are healthy. It is blind when the interesting call is rare. Think auth failures, one tenant's poison payload, a checkout path that only breaks under a specific cart shape. Those are often the thin tail of your latency distribution. Head sampling does not know they were interesting. It only knew the coin flip at span 0, before latency was measured, before status codes existed, before the attribute that would have screamed keep me. So when the page arrives, you're debugging a system that never retained the evidence. The sampler optimized bytes. The incident needed a story. If your SDK already drops 99%, no collector policy can invent the missing spans. Remember that when someone proposes, just add tail sampling on top of aggressive head sampling and walks away. Tail sampling flips the order. Spans still flow in. You buffer them per trace ID until you can ask war room questions. Was end-to-end latency over your burn threshold? Did any span land an error status? Does an attribute mark checkout or the tenant that is paging you? Then you keep or drop the whole trace as a unit. You are buying truth with memory and a decision weight. That is the trade. Say it out loud so finance and SRE share the same sentence. Not magic. A deliberate delay so the collector sees enough of the story before it chooses. Head sampling asks, are we in the 1%? Tail sampling asks, would I need this at 3 a.m.? Different question, different keep set. In the OpenTelemetry Collector, this is a processor. In config, you will see it as tail-sampling on the traces pipeline. Spans arrive on OTLP, commonly 4317. You often run batch next. Then tail-sampling groups by trace ID, evaluates policies, and forwards only kept traces to exporters. Placement matters. If you drop or truncate before the processor, policies judge a half story. If the SDK already head sampled to dust, the collector cannot resurrect spans that never arrived. Tail sampling is not a time machine. It only chooses among traces you actually sent. If you watch the connectors episode, think of this as the keep set decision before you route tenants to different backends. First decide what is worth keeping, then decide where it goes. Policies should read like pages, not like a taxonomy homework. Start with 3. Latency. Keep traces whose duration crosses the threshold that burns your SLO. For checkout, that might be 2,000 milliseconds. Status code. Keep when any span is error, because empty error traces are how you lose nights. String attribute. Keep when http.route or a custom attribute matches the critical path, feature flag, or tenant ID you care about. In YAML, those show up as policy type latency, with latency_ms or threshold fields, depending on your collector version. Read the processor docs for your exact key names, then pin the version in the video description. Same for status_code and string_attribute. You can add a small probabilistic policy as a baseline, so healthy traffic still paints charts. Do not confuse that baseline with your incident strategy. The keep set is a union. A trace that hits any must-keep policy should survive. Write the policy names in the PR description so the next on-call knows why volume moved after deploy. If product asks why we kept a spike of errors last Tuesday, you point at the policy list, not at vibes.
2 knobs get undertuned until something breaks. Decision wait. How long the processor waits for late spans before it decides. Set it too short, and a slow downstream span arrives after you already dropped the trace. You recreate the empty search just later in the pipeline. Set it too long, and you hold more in-flight trace state in memory. Num traces caps how many traces you buffer at once. Undersize it under load, and you evict work you meant to judge. Load test these like capacity. Watch collector memory when traffic spikes. When the process OOMs overnight, inspect tail sampling before you blame the exporter or Kubernetes being Kubernetes. Record the kept rate and drop reasons after each change. If you cannot explain why a trace vanished, you do not own the sampler yet.
Here is the shape you actually ship. Under receivers, OTLP with gRPC and HTTP on the usual ports, 4317 and 4318 if you expose both. Under processors, list batch, then tail_sampling. Inside tail_sampling, set decision wait. Start near 10 seconds and measure against your slowest legitimate child span. Set num traces for your fan-in, not for a laptop demo. Then policies as a list. One object with name keep slow checkout and type latency. Threshold in milliseconds for the path that pages you. One object with name keep errors and type status code, including error. One object with name keep critical route and type string attribute on the key your runbooks already use. Exporters, OTLP to your backend endpoint. Under service, pipelines, traces, receivers OTLP, processors batch and tail_sampling, exporters your backend. That order is the point. Batch, then decide, then export. Deploy to staging first. Generate synthetic slow traces and error traces. Confirm they survive while boring health checks mostly drop. Then read production kept rate and exporter queue. If you kept 90%, your thresholds are soft always on. Tighten until cost matches budget, and the next red checkout still shows a full tree. Paste the final YAML in the PR. Future you will thank present you.
Footgun 1. SDK head sample at 1% plus collector tail sample. You starved the input. The collector cannot keep what it never saw. Prefer recording more at the edge when you rely on tail policies. Or accept that head sampling is your real policy and stop expecting miracles downstream. Footgun 2. Decision wait shorter than your worst real propagation delay. Footgun 3. Keep all errors with unbounded attributes. Every unique poison field becomes a forever cost. Bound what you index. Footgun 4. Running tail sampling after you already fan out to multiple exporters inconsistently. Decide once. Export the same keep set. Footgun 5. Changing policies mid-incident without capturing the old kept rate. You will not know if the empty UI is sampling or a missing instrument. Footguns 6, copying blog defaults for num traces into a multi-tenant gateway collector. Those numbers were not sized for your cardinality.
Before you close this tab, lock 3 actions. 1. Turn war room questions into policies: latency, error status, critical attribute. 2. Set decision weight and num traces from a load test. Then watch memory and kept rate after deploy. 3. On the next page, search the request ID you care about. If it is missing, ask whether it was kept, not whether the UI is broken. Head sampling optimizes cost early. Tail sampling spends a little memory so incidents stay tellable. Pair this with the connectors episode when you route tenants across pipelines, keep the right traces, then send them to the right backend. If OpenTelemetry 101 was the mental model, this is the keep set that makes that model honest under load. Ship the YAML, verify on the next red checkout. That is the whole job. Subscribe if you want the next collector deep dive. Memory limiter and batch, the 2 processors that stop the OOM pager.